All right, so let's jump out of the systems of equations for a while and head into transformations. So when we're dealing with transformations, there are four different transformations. These are all going to take place on the coordinate plane. So we're going to have to be plotting points. That means you have to be good at finding locations on the coordinate plane using the x and the y value, and then moving those locations. And sometimes the move is going to be a translation. A translation is nothing but a slide on that coordinate plane. Sometimes it's going to be a rotation. A rotation means that we're kind of taking the coordinate plane and we're turning it a certain number of degrees. We're going to focus mostly on 90 degrees, 180 degrees, and 270 degrees. And then redrawing the shape after that rotation. A reflection means that we have a particular line that's going to act like our mirror. A lot of times, probably most of the time, our lines of reflection are going to be either the x-axis or the y-axis. So if it's the y-axis, we're going to reflect left to right or right to left, depending on where the shape is. If it's the x-axis, we're going to reflect up or down. Okay, again, depending on where the original shape is. And then we have our dilations. Dilations are nothing but increasing the size or shrinking the size. Okay, when you walk into a bathroom at home, turn the lights on, look at your eyes in the mirror, okay, with the lights on. What you're going to see is that your pupils have dilated, they have shrunk. Then turn the lights off, stand in a very dark bathroom for a while, flip the lights on, and look at your eyes. Your eyes will be wide open, your pupils will be wide open, and as they adjust to the light, they'll start to close. Okay, and you can watch that happen. That's a dilation. That's the same type of thing that we're going to do with shapes. We're going to make them either larger or smaller. So first we're going to take a look at translation. A translation, again, is a slide taking a shape on the coordinate plane and moving it. Okay. Now ignore the due date here. This is not accurate. This was taken from another year. Okay. So we take a look at transformations introduction. You are going to translate point A to point A prime. That little tick mark to the right and above A is, we refer to that as prime. Sometimes you're dealing with a second translation of that same point. That would be A double prime. So you would have two of those tick marks. So the first thing we want to do is we want to graph the point -3, 5, and we label it A. So -3, 5. Always start plotting points from the origin. So we're going to start at 0, 0, and we're going to go to the left 3 and up 5, and that puts us right here. And they suggested we label that point A. Okay, now graph the point 2, 4, and label it A prime. So we're going to go to the right 2 and up 4, and we're going to call that A prime. So usually I just put, almost looks like a number 1 for my prime. Okay. Now, what they're asking us to do is to write out how you could describe the movement from A to A prime. Okay, how would I get, if these were city blocks and I were to walk them, how would I get from point A to point A prime? Well, I would simply say that I'm going to get my highlighter or my laser, and I would take this point A and I would move it 1, 2, 3, 4, 5 to the right. So I'm going to write that down. Right 5. And then here I am at right 5. I have to go down 1 to land right on top of A prime. So I write that down. Down 1. Okay. So we take a look at how do the coordinates change from A to A prime. So we're going to fill in the blanks. Well, from -3, 5, what I did, as I just illustrated there, for my x value, I moved 1, 2, 3, 4, 5 to the right. So I took my x value and I added 5. And I took my y value. Sorry for the interruption, and it's probably going to be, my voice is probably going to be louder now. For some reason it does that every time I pause it and start it up again. Anyhow, so from 5 I went down 1. So this right here says 5 minus what? What are we subtracting? We're subtracting 1. Okay, and that gives us our new coordinate, and that new coordinate is positive 2, comma 4. Okay, that's where A prime is now located. All right, that's for a single point. So now we're going to do the same process with a triangle. Okay, so we're going to go ahead and we're going to take point A and graph it. Point A is at -3, up 5, so that's the same place as the original A was in the previous example. Point B is to the left 6 and up 2. And point C is to the left 2 and up 1. Now what we are creating here is a triangle. So now I bring the sides together, or the points, if you will. And don't worry about whether it's a little bit wavy lines or whatever. It's not real easy to draw on the iPad. Okay, so now graph and label the points A prime, B prime, and C prime. So A prime is to the right 2 and up 4, where our A prime was in the previous example. B prime is left 1 and up 1. You can see now that that gets real close to the other shape. And point C prime is to the right 3 and up 0. There's our C prime. Now, what I like to do, in order to distinguish even more between the original shape and the translation, I like to shade in one of the two. And it really doesn't matter which one. Well, let's call that our original shape. Okay, you don't have to shade the whole thing in, just enough. Write out how you could describe the translation of triangle ABC to triangle A prime, B prime, C prime. Well, it's the same thing as what we talked about before with the previous example. In fact, it's exactly the same description. Right 5, down 1. Now let's check and see if that's true. So if I go from, we already know point A to A prime that's true. So let's go from B to B prime. So we go 1, 2, 3, 4, 5, and down 1. I land right on top of B prime. From C to C prime, 1, 2, 3, 4, 5, and down 1, land right on top of C prime. Okay, so how do the coordinates from the points in triangle ABC change when they get translated to A prime, B prime, C prime? It's the same thing as what we talked about above. The x value, my pen back, we add 5, and the y value, we subtract 1. Okay, so I do that to each x and each y. So I really don't even need to have the coordinate plane here. I can simply look at these x and y values, and I can do exactly what it says in the rule. So if I look back up here, you can see where my pointer is, I hope. We have a -3. If I add 5 to -3, I get +2. This is to the right 2. If I take the 5 and I subtract 1, 5 minus 1 is 4, and this is up 4. Same thing with the b to the b prime. In order to get to there, I take my b value, which was -6, and add 5, I get -1. You can see I'm to the left 1. I take the 2 and I subtract 1, and that leaves me at positive 1. So left 1, up 1. Okay, so that rule will still work for every single one of the points. Same idea with the next example. Next example, you'll now translate triangle XYZ, where X, Y, and Z are given. And then we're going to translate based on a rule instead of them giving us the coordinates. Okay, so I'm going to take that first point, X, that was to the left 5 and up 2. Puts me right there. There's point X. Point Y was to the left 4 and up 1. And point Z was to the left 0, down 3. This is a really awkward triangle. But let's see if I can connect them. It really ends up being a very flat triangle. That was a mess. Let me try that again. Okay. Almost looks like it lands right on top of itself. I don't think it does. Actually, it does. Don't know why they did that. Very odd. So it actually technically goes right on top of the other line. What I mean by that is from X all the way over to Z follows the same line as Y to Z if you're using these coordinates. And I think I got all the coordinates correct. I did. Okay. Now we're going to translate this supposed triangle by the rule add 3 to each of the X values and subtract 2 from each of the Y values. So add 3 to each of the X values. Well, if I take the X value of 5 and I add negative 5 rather, and I add 3 to that, I get negative 2. Okay, and sometimes I write right underneath there plus 3. And the Y value is a minus 2. Okay, so if I take 2 and subtract 2, I get 0. The next X value, plus 3, that gives me a positive 1. Minus 2, 1 minus 2 is negative 1. 0 plus 3, I wrote a 5 there accidentally for the previous one. Let me erase that. That should be a plus 3. So here's a plus 3. 3 plus 0 plus 3 rather is 3. And a minus 2 gives me negative 5. And then I plot those new points. Left 2, up 0. I'm going to put these in a different color. Right 1, down 1. And right 3, down 5. Must have done something wrong here. It looks like it's not nearly as flat as the other one. I don't know what I did wrong on the first one, but something. Negative 4 plus 1 over 0, down 3. Maybe their graph is pinched in or something, because this definitely looks like a better triangle than the previous one. Now I'm going to mark the corners, the vertices, in black. Those are X prime, Y prime, Z prime, and I'll connect them in red. Okay. All right, there we go. So there is our new shape. Again, it does not look the same. Not sure what happened with that, but again, maybe their spacing is a little bit different as we go off the graph or further over on the graph. Anyhow, that's our new shape. So that is our translation from x, y, z to x prime, y prime, z prime. And the final example I would like you to try on your own. I am going to help you out by giving or writing in the rule that they're talking about. So we're going to use a rule here of subtract 4 from the x and add 3 to the y. So minus 4 plus 3. So every single x value we're going to take away 4, and every single y value we're going to add 3. So that's literally just taking those numbers and adding or subtracting, and that will give us our new x and y values. Okay, so I want you to give that a try, and I'd like to look at that in class.